Hello, this is Richard Wendel, and this is my submission for the Lab 11/12 Checkoff video. To begin with, I will explain which each of the individual components will do, and then to start, we have switches 0 through 2, which will represent our Y inputs, and basically the Y inputs, when converted from the binary representation to decimal form, will demonstrate what register will be selected. Then we have switches 4 through 6, which do the same thing, except they'll be considered input X, and then we have switches 6 through 8, which are going to be our instruction bits, which, depending on the configuration, will tell the circuit which operation to perform. Then we have a switch 9, which represents our data input, or not our data input, our run input, which is basically just an enable for the rest of the switch that allows operations to be performed. Then for our buttons, we have button 0 up top, which represents a reset button, which when pressed will remove all the information from the registers and take away what was ever on the bus. And then we have the bottom button 1, which will act as our clock impulse. When pressed, it will activate all the rising edge operations. And then for our LEDs, they represent the bus, which the aforementioned bus, which is basically just a 9-bit holding state for various data, and then depending on the operation, it will be going into and out of registers, or depending on which multiplexer line is selected, it will go, or it will be able to have operations performed or transfer between registers. And finally, we have LED 9, which will represent our done input, which is basically signifying to us that the operation that we desired is completed. Okay, and then to continue with our logic abstraction, when any of the switches or buttons are down or not pressed, that means that it is in logic 0. Whenever it is up or pressed, logic 1, and when the LEDs are off, that would be a logic 0, and then on would be a logic 1. Okay, and to begin with, our first operation will be to move the binary equivalent of decimal number 4 into the 6th register. And then to begin with, we're going to turn on our run input, which will then allow any of the operations to be continued. We're going to be selecting 001, which that represents the state of being able to move data immediately into a specific register. And then we'll be using the X input registers, and those will be able to basically just tell us what register will be used. So then we're going to be doing 110, because whenever you convert that into decimal, that'll be equivalent to register number 6. And then we won't be using the Y input, so they can just not be incorporated. And then you can see that the basically whatever switch we put up besides our run switch is being represented on the bus. And that is just because in the initial state that we are in, the register that holds all the instructions is currently in an on state, and that is selected by the multiplexer, which then, as a result, in this specific instance, in the initial state before any operation is selected, it'll show that on the bus line, I guess. Okay, and then if we go to the button, we click button. Awesome, so it shows done. And in this instance, that basically just gives us the opportunity then to type, or to put the binary equivalent of the decimal, or the binary equivalent of the decimal number we want inserted into that specific register. And then, because we are technically still in the 0 state, that all the data inputs that we're putting in are still going to be represented on the bus. So then, because we are putting in 4, we're selecting that, and then press it. Awesome. So then, now that it is off, that allows us to select a new operation to perform. And then we're now moving the 6, or the decimal equivalent of 4, into the 2nd register. So we're going to be taking the data from number 6, keeping it in the 6th register, but just transferring what was inside it into the 2nd register. And then to start that, we're going to not incorporate any of the instruction bits, because whenever none of them are selected, that represents the move data input instruction, which will then allows us to perform the operation we desire. And then we're going to use the Y inputs to select the data the register we're taking data from, which is 6. And then we're going to use the X inputs to select the register we want to move the data into, which is 2. Awesome, and then we can then click that. There we go. And then now that the information that was in the R6 register is now put on the bus because it was selected by the multiplexer, and then the finite state machine that we devised now allows us to send the input to the second register to activate that. And then because the information was on the bus and it's connected to each of the registers, the register number 2, which is the only one active right now, will be receiving the 4, which is represented on the bus currently. Okay, and then next we're going to be doing adding between register 6 and register 6. And so we can then select our add input, which is 0, 1, 0. And then you won't be able to notice, but we are changing the switches because it's not on the clock pulse. It's just keeping whatever was previously on the bus there. So then we have 0, 1, 0 representing add, and then we have to select 6 for both of them. And then that will again store it in register 6. Just making sure we got that. Awesome. So we click the button once, and then that then puts the data input back onto the bus. So all the switches that are up now have or besides the run input, of course, now has the data being displayed on the bus. Press it again. Now it takes since the adder that is being applied is utilized, we're sending the information from the 6th register into the bus onto the bus line, and then we're activating the next register to store the result from this register 6 plus register 6 operation, and then press that. Now what we have now done, we have now 4 plus 4, which equals 8, and now that's not on the bus and now currently stored in register 6 because that is again that was selected, or the register 6 enable switch was selected by the multiplexer and to receive whatever data was on the bus. And then next we're subtracting 6 from 2, or register 2. So then we're going to select our subtraction bit, which is 0, 1, 1, and then we're going to be selecting register 6 with our X inputs. So we got 4 plus 2, 6, and then we're going to be selecting register 2 with our Y inputs. Awesome. So we click that. Same thing gets applied, where whenever we press the clock impulse button again, well, the data that it was being displayed through the switches are now being put onto the bus line. Click it again. That is the first. That is what is the data in register 6 being subtracted from the data in register 4, or register 2, excuse me, which is 4. So now we have 8 minus 4. Then all we have to do is now put it back on the bus. Awesome. And there we go. And then as a result, the data in register 6 will now contain 4, which is the result of 8 minus 4. Awesome. Well, thank you. And thanks for the great semester, guys.